Hi, my name is Miguel Parrella. I'm with the Open Source Strategy team here at Microsoft. Today I'm going to show you how to connect a Linux and attach devices on an Internet of Things scenario to Microsoft Azure, and how to see some of the log files and messages and logs using Azure Service Bus and Azure Web Sites and Node.js and some other really sweet Linux integration components. So the first thing we'll do is we'll create a new website. I'm on the Azure Management Portal on the browser. I just create a quick create of a website. Let's call it Linux IoT 01. And then I have WebSockets. I'll create my website right there. So this is going to be an empty website, and I can deploy any Node.js, PHP, Java web application container, Python application, or obviously an ASP.NET application as well. What I'll do now is just get the Git repository for this, because there are several ways I can deploy to this site. I can use FTP, I can use Web Matrix, I can use several other deployment mechanisms, but I'm going to choose my own Git repository. So on my dashboard I can just set up deployment from source control, which is one of the options right here. As I mentioned, I have Visual Studio Online and some other choices here. I'm going to choose a local Git repository, and basically what this will do is it'll create a new tab with information on my deployments, and it's going to give me the address of the Git repo that I can use. So I'm going to take that Git URL, and I am going to just so we know that it's working, I'm going to clone it on a Linux VM. So this is going to ask me for a password, which is a deployment user password that I have set on the Azure Management Portal. So I'm just going to input that, and I'm going to be cloning an empty repository because there's nothing on my site today. So I can just change into that directory, and it's completely empty. So now that we've done that, I'm just going to go to the Configure tab, and I'm going to enable WebSockets. Just as I have created this website, it's running on free mode, so I get just a handful of WebSockets supported, but I'm also not getting charged for running this website, which is kind of neat if I'm doing some tests. So I'm just going to switch WebSockets to on, and I'm going to save. Notice that I have several options here on Python, Java, PHP versions, etc. Git is on the Azure side is smart enough to detect which application I'm deploying, and it will make the choices correctly on the server side. So that's everything I need to do from a management portal perspective. Now let's go and look at the actual code of this little demo here. So I'm going to use a publisher subscriber model. I'm going to have Node.js application running on a Linux Raspberry Pi device. And this application is going to look at messages being sent by a Pinguino board, which is a grassroots Arduino device that has a very simple chip on it, and it's generating some random numbers on a few seconds apart, and then it's going to look at the USB communication link. It's going to look at those messages, then it's going to use the Node.js SDK for Azure, and it's going to send that to Azure Service Bus. That's going to be my publisher. And then on the subscriber side, I'm going to deploy a small Node.js application to the website that I just created. This is going to subscribe to the Service Bus topic. It's going to look at the messages that are being sent to that Service Bus, and then it's going to expose that through a WebSocket. So then my let's say my simple front end is just an HTML file with a bit of JavaScript that connects to the WebSocket and actually shows me the messages. So the code supporting this demo is available on GitHub. So the simple on the simple publisher side, I just take standard input from any command, and I'm gonna push it to the cloud. I just need the connection string for my service bus, and then the topic name. I have this is going to use a RESTful interface. Azure also supports AMQP, and I have a PHP demo as well if you want to use that. So the way I would use this is just tail the log file and then send that as standard input for my other command. The good thing is that I can integrate with bar log files, and I can use Logger or other utilities to actually send those messages. The actual code of the Node.js publisher looks like this. It's pretty simple. I'm using I'm using the Azure libraries, and I'm using some Node.js library to make sure that I can operate on a standard input. Basically, I just look at my connection string and the topic name, and then I just take the lines that I get from standard input and send that to the service bus as part of a specific topic that I have created. The service bus is created also from the management portal. I can also use PowerShell or the Azure command line tools for Linux and Mac if I want to use that. But it's also pretty simple. I just need to make sure that my service bus has been created, and I create a topic as part of that service bus. It will look somehow like this. I have already created one here, and I need to create the policies that applications will use to access it. I just I might have subscribers that I just want them to read the messages. I might want different policies to access this. So I already have a service bus running. I have a topic created right there. I can see if I have subscriptions. In this case, it was accessed just a few minutes ago as I was doing some tests. And as I said, I have subscriptions here that I kind of define. In this case, I should have a dashboard, which is the website part of the solution that I'm building here. So the Raspberry Pi is already powered on. I have OpenVPN configured there, so just so I can log in back to my Raspberry Pi device, since I don't have an HDMI screen around. So I just log to my Raspberry Pi, and basically what I have here is I just have a UDEV rule on Linux, which is basically expecting a Pinguino device that's gonna create a TTY ACM0 device, and then once that's running, it's gonna call a shell script. This shell script, I also, for the sake of making a full architecture, I also divided it in two, and then this the actual shell script here is calling my AZPipe JavaScript application. It's going to use my endpoint and the rest of my connection string, and it's going to send to this topic alpha. So it's basically going to take everything that comes out of this device and it's going to send that to the cloud. It's as simple as this. I did this way because I wanted to run kind of like a daemon. So it's always going to be running, and it's only going to be running when I connect the device and the ACM link is present. Otherwise, it's not gonna be sending anything to the cloud. So I can have a more kind of reliable functioning situation here. So what I'll do now is I'll actually connect the Pinguino. So I just plug that in. The USB cable is providing energy as well, and then so after a few seconds on my USB devices, I should see the microchip technology. Yep, that's exactly the name of the device that I just connected. I should also see that now there is this AZPipe application running, and it's sending all the data that's coming from the TTY ACM0 device, which is going to look something like this. So let's try to do this, and after a couple seconds we should be able to see a little bit of what's that Pinguino says, and then some random numbers. This is code that you actually write and put in the chip on that Pinguino device. You would do this on C or any of the other languages that are around for those application development. And this is being sent to the cloud, so I can just see it on my dashboard. So what I'll do on the Raspberry Pi now, I'm going to clone my Git repository for the website. So in this way, I will be able to copy the code of the subscriber. So just as a reminder, you can go to your website and click on deployments, and then you can get the Git URL for your specific website. So let's just clone it right here. You're going to have to input your password as well. After you do that, on the Raspberry Pi, I already have that the code of the subscriber, but you have it on GitHub as well. So just go, instead of going to dep-pub, go to -sub, which would be the dashboard or subscriber. So it's a simple Node.js application. It also has a connection string to the service bus. It also uses, so this one's using Express, so I have a simple HTML file, a static file there. So it's creating a WebSocket server. It's listening on my on my web server port, and it's creating a WebSocket server on that same server, and it's looking for the connection string, subscription, and topic. And then basically it's just waiting for connections, and when there's a message on my service bus, it's going to send it to all the connections through the WebSocket. It's as simple as it is. I'm going to just check the HTML file, which has the JavaScript content as well. So it's just a simple view.html. This is connecting to the WebSocket, as you can see. And when I get a message, I'm just outputting it to pound output right here, which is this div right here. So it's going to be a very simple, no fancy visuals or anything like that, but it's going to be a pretty simple way to illustrate how you can connect a Linux device and even Arduino and Pinguino boards or any other sensors to Microsoft Cloud through Azure. So this is my empty repository. I already have my subscriber code right here. I'm just going to copy it over. So see that I have the application file, the config with my connection strings and my package.json and the public directory with the view.html file in it. So I'm just going to add that to Git. I'm going to make an initial commit, and I'm going to push that. So as I told you, when you push this code, regardless of whether it's a PHP or Node.js code, on the server side, Azure is going to detect whether you're doing a Node.js website, which is right here. So it's a deployment script for Node.js side, and then it gets all the necessary modules and finally makes the actual deployment and running of the app.js on the server side. So also on the portal, when I'm deploying, it should also be possible to look at what specifically it's going on with the site. So if I have several deployments, or I'm doing kind of continuous integration, I can also look at that from the management portal as well. So it's getting all the modules now. Depending on how many modules your application is using, it will take more or less time. And then finally, that I have completed with a successful deployment, my application should be running on the Azure side. I just need to browse to it. I'm gonna see probably a placeholder image because index.html is not actually available. I'm gonna see 404, and if I browse to view.html, I should see my device dashboard, and then I'm seeing all the messages that the Pinguino device is sending. And just to make sure, this is a WebSocket, so I'm running Explorer, some version of Internet Explorer that has WebSocket support. I'm seeing all the messages generated by that little Pinguino board connected to my Raspberry Pi. So several things here. The architecture is overly complex just to accommodate for scale. Service bus is there exactly to make sure that we have high throughput of messages from several devices. The publisher subscriber model also accommodates for several devices, several dashboards, and several other reporting mechanisms working there. Obviously, this is not aware of the actual content of the messages or of the sensors, the random information that I'm getting from the Pinguino device. So it's if you're looking into something more elaborated on that respect, you should look into the intelligent system services that Microsoft has recently announced, which will include some level of Linux support as well. But this is a good way to illustrate how you can use Azure Service Bus, Azure Web Sites, and Node.js support, the open source SDK for Node.js on Windows Azure, and some of the other resources available from the cloud to make sure that you connect your Linux things to the Microsoft-based public cloud and solutions. So hopefully this has been illustrative for you. Make sure to check out the code on GitHub if you wanna take a look at the code and how it's built. And also remember that on the publisher side, you will have a PHP example using AMQP if you want to explore that specific protocol. Thanks for watching.